Alright, we're going to talk about relations and how relations can be functions. A relation is actually just a set of ordered pairs. Just a bunch of pairs. Okay. X's and Y's, X's and Y's. The domain of a relation is actually the set of first coordinates. The set of first coordinates is actually all of the X's. This is the first coordinates of the ordered pairs, i.e. the X's. The range, or capital R, of a relation is actually the set of all second coordinates, which is actually all the Y's. So again, it's the second coordinates of the ordered pairs, i.e. the Y's. In graphing a relation, the horizontal axis is actually called the domain axis, and the vertical is called the range axis. This idea of axis names, for example, we understand the Cartesian coordinate system that this is the x-axis and this is the y-axis. The x-axis makes a horizontal line, so we can call this also the horizontal axis. Also, the set of all x's is known as the domain, so we can call this the domain axis as well. This vertical is the y-axis, so we can call it the y-axis. We can also call it the vertical axis. The set of all y's is the range. We can also call this the range axis. Okay, let's go back. So we have the domain and range can actually often be determined from the graph of your relation. We're going to talk about how to write your domain and range in set notation and interval notation using parentheses and brackets here in just a moment. First thing we want to talk about is, if I give you a relation, just a set of ordered pairs, can you figure out what the domain and the range are? Well, again, the domain, or capital D, is the set of all x's. Well, what are the x's that you see? A -1, a 1, and a 0. Therefore, that's your domain. The set of the range, or capital R, is the set of all y's. Well, what are the y's that you see? Well, I see a 1, a 5, and a 3. So, that means that my range is 1, 5, and 3. Okay? Let's talk about how relations can sometimes be special in that they are functions. So a function is actually a special kind of relation that pairs each element of the domain with one and only one element of the range. Again, said a different way, basically each x goes to one and only one y. Another way, the x's don't repeat. To understand this is that, for example, we have relations, okay, lots and lots of sets of ordered pairs. Within this set, we have a subset called functions. And in this subset, these functions, every x shows up one time in the listing of your relation. So if we go to a listing of a relation and try and understand which ones are functions and which ones are not, basically we're going to concentrate our efforts on looking at the x's and seeing, do they repeat? Yes or no. So which of the following relations are functions? There's a 2 that goes with a -8, a 3 that goes with a 0, and a -1 that goes with 5. The x's did not repeat. Each x goes to one and only one y, therefore yes, this is a function. Let's look at this one. 2 goes to 5, 3 goes to 5, and -1 goes to 5. Did the x's repeat? No. So, yes, this is a function. Keep in mind that it's okay if the y's repeat. You see how every single one of these goes to a 5? It's perfectly fine. It's the x's that we care about. Let's look at the next one. 2 goes to 5, 3 goes to 0, and 2 goes to 0. Did the x's repeat? Yes, they did. 2 went to 5, but also went to 0. Since the x of 2 repeated, this is no, not a function. This is how we can tell if a relation is a function based on the ordered pairs. How would I tell if a relation is a function based on the graph? Well, that we use what we call the vertical line test. So to determine whether or not the graph of a relation represents a function, we apply the vertical line test, which states that if any vertical line intersects the graph of your relation in more than one point, then it is not a function. Okay, so let's look at that with a couple of examples here. Okay, I have my relation is here. My relation for another one. Here's another one. Just making it a little darker here. Okay, now, each one of these is a relation. And the question is, of these, which one's a function? So, I'm going to apply my vertical line test. Draw your vertical line on your relation and say, count how many times it touches it. Touched one time, that means this is a function. Touched more than once, not function. This is a vertical line. If I draw a vertical line on a vertical line, how many times am I touching it? Infinitely many, right? This is, okay, so this is the, let's say because it touches more. Okay, here. This, of course, would not be a function because my vertical line is on top of this vertical line, which touches infinitely many times, therefore not a function. And again, because touches more than once. What about this ellipse? Draw a vertical line on my relation. I'm touching it more than once, so not a function. What about this one? We've got a parabola. If I draw a line on my parabola, I'm touching it more than once, so this is not a function. What about this cubic function? Keep in mind that these do not vertical, they keep going out and up. So if I draw a vertical line on my relation, touches it one time, so yeah, this is a function, because it only touched it one time. Here's a circle. You guys can guess what this one's going to be. Draw a vertical line on your relation, touching it more than once, not a function. We have another parabola, concave up parabola. Draw a vertical line on your relation, touching it one time. So yes, this is a function. Okay, let's move on. Let's talk about function notation and evaluating functions. Function notation is the idea of, instead of writing like we've been used to, y equals 2x plus 3, mx plus b. Instead of writing like that, we're now going to, instead of writing y, we're going to write this, for example, as f of x. So keep in mind, f of x is the exact same thing as y. Now the reason we're changing to this notation of f of x is function notation. For example, the f here is just the name of the function. I could say, let that be an h, an r, an s, a t, okay? This letter is just the name of the function. The x goes here because we're talking about f of what's in the domain. X's are in the domain. My function evaluated at x will spit out the output of a y. So again, when we have ordered pairs, x is your input, y is your output. With function notation, we will be inputting the x, we will be getting out the y. So again, f of x. F is the name. X is representative of an element in the domain. 2x plus 3 is just called the function rule. And f of x as a whole is represented, remember f of x is the same thing as y. And y's all together are the range. So f of x, the whole thing, f of x, is representative of an element in the range. Okay, all we need to know about these is how to evaluate. which means if I take my function f of x equals 2x plus 3, and I want to look at, let's say, I want to find f of negative 5. Well, what happened? I was looking at this function. But what happened? My x changed from an x to a negative 5. Oh, okay, so if I change my x on this side, I should change my x on this side. So instead of saying 2 times x plus 3, I'm going to say 2 times negative 5 plus 3. Multiply out 2 times a negative 5. So, finish it out. Negative 7. Now, understand that anytime you evaluate, you will get an ordered pair. An ordered pair is always x comma y. X is the first coordinate or input. Y is the second coordinate or output. Now for this one, what did I input into the function? Well, I inputted a negative 5, therefore my x is negative 5. What did I get out? My output, the end of the problem, right? My output was negative 7, therefore y is negative 7. And this is an ordered pair that you can simply plot on a graph. Now let's understand something. It doesn't always have to be something nice and pretty that you're inputting. I don't always have to put in a number. Let's talk about f of $. Still working with the idea that the function is this. Well, what happened? My x changed from an x to a $, so I need to do the same thing on this side. So instead of saying 2 times x plus 3, I say 2 times $, plus 3. Nothing's like, so I can't do anything more. Good question though, what if I wanted f of smiley face? Well, it's the same kind of thing. Instead of having an f of x, I have an f of smiley face. So I'm going to have 2 times smiley face plus 3. Again, none of these are alike, so I leave it as is. You can do this, okay, it doesn't matter. It does not matter what the input is, as long as you do it the exact same way. Now keep that in mind as we move to this one. We are still looking at the function 2x plus 3. However, f of x, my x changed from an x to an x plus 1. So if it changed on this side, it needs to change on this side. So instead of saying 2x plus 3, I'll say 2, open up a parenthesis, x plus 1. Why am I putting a parenthesis in here? I'm putting this parenthesis here because we always need to think about when we input something, put a parenthesis around it. It's just good practice. That way, when you get to something where you're inputting more than one value, you can look at this and go, oh, I need to distribute. So again, whenever you input something, put parentheses around it so that you can clearly see that now you've got to distribute. Distribute to the first, 2x. Distribute to the second. Remember, this is multiplication. 2 times 1. Combine your like terms. Now remember what I said. I said you always get an ordered pair. Ordered pairs don't have to be pretty. Again, this is your input. This is your output. Well, what did I input into this function? X plus 1. And what did I get out? 2x plus 5. It's not pretty, but it's an ordered pair.